Hi everyone, in this recording we'll be going over synthetic division of polynomial functions of higher degree. So by the end of this recording, our goal is that you'll be familiar with how to divide polynomials using long division, how to use synthetic division for divisors of the form x minus k, how to use the remainder theorem to evaluate polynomial functions, and how to use the factor theorem to identify factors. So the first thing we'll be going over is the long division of polynomials. So we are told to consider the function f of x is equal to 6x cubed minus 19x squared plus 16x minus 4. So the graph shows that x is equal to 2 is one of the zeros of f of x. So if x is equal to 2 is a 0, then x minus 2 is a factor of f of x. So that means f of x can be written in the form x minus 2 times some q of x, such that q of x is a polynomial. So in order to find that q of x, we can divide f of x by x minus 2. So by doing that, first we rewrite our 6x cubed minus 19x squared plus 16x minus 4, and we divide it by x minus 2. So the first term will be 6x cubed divided by x. That'll give us 6x squared. So you can multiply that 6x squared by the x minus 2, so that'll give us 6x cubed minus 12x squared. Now we subtract. So 6x cubed minus 6x cubed cancels out. Negative 19x squared plus 12x squared gives us negative 7x squared. So now we can bring down the 16x term. So now negative 7x squared divided by x is equal to negative 7x. So now we can multiply back the negative 7x to the x minus 2, and that'll give us negative 7x squared plus 14x. So now we can subtract. Negative 7x squared plus 7x squared cancels out, and 16x minus 14x will give us positive 2x. Now we can bring down the last term, which is negative 4. So 2x divided by x gives us positive 2. So now multiplying back the 2, 2 times x is 2x, and 2 times negative 2 is negative 4. So 2x minus 4 minus 2x minus 4 is equal to 0. So we have a remainder of 0, so that means that the division is exact, and our quotient, 6x cubed minus 7x plus 2, is our q of x. So that means f of x is equal to x minus 2 times 6x squared minus 7x plus 2. So now from the division, we can see that our original function, 6x cubed minus 19x squared plus 16x minus 4, can be written as x minus 2 times some quadratic. And now that quadratic will be easier to factor. So we have the quadratic 6x squared minus 7x plus 2, the one that we just obtained from division. And upon factoring that, we'll get 2x minus 1 times 3x minus 2. So now the final factored form is x minus 2 times 2x minus 1 times 3x minus 2. Now we can set each of those portions equal to 0 and get all three of our x intercepts. And we see that they occur at x is equal to 1/2, x is equal to 2/3, and at x is equal to 2. So the goal of dividing polynomials is to break a polynomial into factors, then reduce the degree of the problem, and find the missing factors after 1 0 is known. From there, we can better graph the function. So the zeros will tell us where the function crosses or touches the x-axis, and the division helps us rewrite f of x. So a lower degree quotient is easier to analyze. So here are the steps that we followed for long division. So first we wrote the terms in descending powers. Then we include missing powers with a coefficient of 0. And then we divide the first term by the first term of the divisor. We multiply that back, subtract, and bring down the next term. We repeat this process until the remainder has a lower degree than the divisor. So here we're given another example. We're given the function f of x is equal to x cubed minus 1, and we're told to divide by x minus 1. So the first step is to write the dividend. So since we have no x squared term or x term in the x cubed minus 1, we can rewrite with 0 times x squared plus 0 times x, so they can serve as placeholders. So now we have x cubed plus 0 times x squared plus 0 times x minus 1 divided by x minus 1. So first we divide the x cubed by x. So x cubed divided by x will give us x squared. Now we multiply the x squared back to the x minus 1, so we'll have x cubed minus x squared. So now we can subtract those two terms, and we're left with x squared. Now we can bring down the 0 times x term, and we can divide by x. So x squared divided by x will give us x. So then we can multiply that x back into the x minus 1. So we're left with x squared minus x. Now we can subtract those two, and we're left with x. Now we can bring down the negative 1 and divide x by x, so that will give us 1. So now we can multiply back the 1 times x minus 1, and we're left with x minus 1. Now we can subtract those two terms, and we're left with a remainder of 0. So x minus 1 divides evenly into x cubed minus 1. So the result is that x cubed minus 1 divided by x minus 1 will give us x squared plus x plus 1, for x is not equal to 1. Now we can check by multiplication by multiplying back the x minus 1 times the x squared plus x plus 1, and we see that we get the original dividend. So then that means our answer is complete. So here we're given another example, but this time we are dividing by a trinomial. So we're given the function negative 5x squared minus 2 plus 3x plus 2x to the power 4 plus 4x cubed, and we're dividing that by 2x minus 3 plus x squared. So we see that the powers are not in descending order, so we rewrite. So now we are left with 2x to the power 4 plus 4x cubed minus 5x squared plus 3x minus 2 for the dividend, and for the divisor we have x squared plus 2x minus 3, and now we can divide. So we divide 2x to the power 4 by x squared, and that'll give us 2x squared. So we can multiply that back by the divisor. So 2x squared times x squared gives us 2x to the power 4. 2x squared times 2x gives us 4x cubed, and 2x squared times negative 3 will give us negative 6x squared. So upon subtracting those terms, the 2x to the power 4 and the 4x cubed cancel out, and negative 5x squared plus 6x squared gives us x squared. So now we can bring down the 3x term and the negative 2. Now we can divide x squared by x squared, and that'll give us 1, so we can multiply that back by the divisor, and we're left with x squared plus 2x minus 3. So now we can subtract those terms, so the x squared terms cancel out, and we're left with x plus 1. So now we have a remainder of x plus 1, and since the degree of that remainder is 1, and it is less than the divisor's degree, 2, the division stops. So our final answer will be 2x squared plus 1 plus x plus 1 divided by x squared plus 2x minus 3. So now we can check by multiplication. So we can multiply the divisor by 2x squared plus 1 plus x plus 1, and we get the original function. So now we'll be going over synthetic division. So synthetic division is a shortcut for long division when the divisor has the form x minus k. If you're given x plus k, that is the same thing as saying x minus negative k. So to divide ax cubed plus bx squared plus cx plus d by x minus k, first we write all the coefficients of the dividend, so the a, b, c, and d. On the outside of the box, we write the k, and for the vertical pattern, we will be adding the terms in the columns. So for the first term, the a, we just bring it down. Then for the diagonal pattern, we will multiply the result by k. And we see that the last term, little r, is our remainder. So now we'll be going over an example. So we are told to divide the function x to the power of 4 minus 10x squared minus 2x plus 4 by x plus 3. So x plus 3 is the same thing as saying x minus negative 3. So then our k is equal to negative 3, and we will write that on the outside of the box. Since we have no x cubed term, for that coefficient, we will just write a 0. So for a, we have 1, since we have x to the power of 4. For b, we'll have 0. For c, we'll have negative 10, since we have negative 10x squared. For d, we'll have negative 2. For e, we'll have 4. So now we bring down the first term, so 1. We bring that down. Now we multiply 1 by negative 3. So 1 times negative 3 is negative 3. Now we add the 0 and the negative 3 for the vertical pattern. So 0 plus negative 3 is equal to negative 3. Now we multiply negative 3 times negative 3, and that'll give us positive 9. Now we add the negative 10 and the 9. That'll give us negative 1. So negative 1 times negative 3 is equal to positive 3. Now we add negative 2 plus 3. That'll give us positive 1. Then we multiply for the last time. 1 times negative 3 is equal to negative 3. So now 4 minus 3 is equal to positive 1. So our remainder is 1. So then our final answer will be x cubed minus 3x squared minus x plus 1 divided by x plus 3. Now to check our answer, we can multiply x plus 3 by x cubed minus 3x squared minus x plus 1 again, and we will get x to the power of 4 minus 10x squared minus 2x plus 4. So now we'll be going over the remainder and factor theorems. So the core idea of the remainder theorem is that if a polynomial f of x is divided by x minus k, then the remainder is r, and that will be equal to f of k. So synthetic division can be used to evaluate a polynomial at x is equal to k because the remainder obtained equals f of k. Now for the factor theorem, x minus k is a factor of f of x if and only if f of k is equal to 0. So a remainder of 0 when dividing x minus k means that the divisor x minus k is a factor of f of x. So here's an example using synthetic division to divide the function f of x is equal to 3x cubed plus 8x squared plus 5x minus 7 when x is equal to negative 2. So we have our coefficients on the top, 3, 8, 5, and negative 7. And on the outside, for k is equal to negative 2, we will write negative 2. So the first step is bring down the positive 3. Now we do k times a, which is negative 2 times 3, and that will give us negative 6. Now we add 8 plus negative 6 will give us positive 2. Now we multiply negative 2 times 2, that gives us negative 4. Now we add 5 minus 4 is equal to 1. Now we multiply 1 times negative 2 is equal to negative 2, and now we can add negative 7 plus negative 2 is equal to negative 9. So the remainder is negative 9. So that means f of negative 2 will equal negative 9. And that means the point negative 2 comma negative 9 is a point on the graph of f. So we can double check by substitution, so that is by plugging in the negative 2 into the function. So 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. So negative 2 cubed is negative 8, negative 2 squared is positive 4, so then 3 times negative 8 is negative 24, 8 times 4 is 32, and 5 times negative 2 is negative 10, and negative 7. So upon simplifying, we get negative 9. So our check is complete. So a quick takeaway is that the remainder after dividing by x minus k should equal f of k. And if f of k is equal to 0, then x minus k is a factor. So now we'll be going over the factor theorem. So a polynomial f of x has a factor x minus k if and only if f of k is equal to 0. So to test whether x minus k is a factor, we evaluate the polynomial at x is equal to k. If the result is 0, then x minus k is a factor. So for example, we need to show x minus 2 and x plus 3 are factors of f of x is equal to 2x to the power of 4 plus 7x cubed minus 4x squared minus 27x minus 18. So first off, for x minus 2, that means our k will be equal to 2. Now we write all of our coefficients on the top, so 2, 7, negative 4, negative 27, and negative 18. The first step is bring down the a, which is 2. Now we multiply k times a, so 2 times 2 is 4. So 7 plus 4 will be 11. Now 11 times 2 give us 22. Now negative 4 plus 22 gives us 18. Now 18 times 2 will give us 36. And negative 27 plus 36 will give us 9. Now 9 times 2 will give us 18. And negative 18 plus 18 is equal to 0. So we have a remainder of 0. So that means x minus 2 is a factor of 2x to the power of 4 plus 7x cubed minus 4x squared minus 27x minus 18. Now we repeat the process with x plus 3. So now, in this case, our k is equal to negative 3, and we write our coefficients. This time we are writing the coefficients of the quotient, the one from the previous, from the first round of division, the 2x cubed plus 11x squared plus 18x plus 9. So now our coefficients are 2, 11, 18, and 9. So the first step is bring down the 2. Now we do k times a, which is negative 3 times 2, so that'll give us negative 6. Now we can add 11 minus 6 is equal to 5. So 5 times negative 3 gives us negative 15. So 18 minus 15 gives us positive 3. So 3 times negative 3 gives us negative 9. And 9 minus 9 is equal to 0. And we have a remainder of 0. So our quotient is 2x squared plus 5x plus 3. And since f of negative 3 is equal to 0, x plus 3 is a factor. So some of the common mistakes that we want to avoid is using synthetic division with x squared plus 1 or 2x minus 3 without adjusting. So we cannot forget the zero coefficients for missing terms. We need those placeholders there so that division is done correctly. Another thing we want to avoid is changing signs incorrectly when the divisor is x plus 4. So in this case, we can rewrite it as x minus negative 4 so that our k is equal to negative 4. Lastly, we don't want to treat a non-zero remainder as a factor.